So we're going to look at one final set of examples involving intersections and unions of intervals, but now our index set will be the positive real numbers. So let's look at the following. I want us to take the intersection of epsilon and r plus, and our interval will be minus epsilon to epsilon. So here, I'm only restricting myself to positive numbers, but they could be real numbers. So I can use fractions now if I want. So epsilon could be 1/2, and then my interval would be negative 1/2 to 1/2. Here to here, not including my endpoints, so open circles there. Epsilon could be a whole number, like 1. I would get the interval negative 1 to 1. But there are other real numbers other than just whole numbers and fractions. You could also look at epsilon being pi, so the interval from negative pi to pi. So I'd probably have to stretch out my picture a whole lot here. I didn't leave myself quite enough room. But here's 0. Pi is a little bit bigger than 3. So if I shade in my region, so you would have an interval like this for every positive real number. And so then you ask yourself, I'm taking an intersection, what do they all have in common? Well, they're all centered about 0, so they all contain 0. So it turns out that this intersection is just going to be 0, and that's it. It's just a single number, and that's my intersection. Now let's look at a union here. So say I want to find the union of epsilon and r plus. And now I'm going to look at the closed interval, minus epsilon to epsilon. So again, you can pick any kind of positive real number you want. So let's just stick with the ones we had before. If epsilon was 1/2, this would be negative 1/2 to 1/2. Now one thing that's changing here is that it's a closed interval now. So I do include my endpoints. Okay. And then we can take epsilon to be 1, negative 1 to 1. So it's pretty much just the same pictures you had before, but now the endpoints are included. So you use filled in circles instead of open circles. You can also use pi again for epsilon. Negative pi to pi. Right, so I'll just shorthand do this kind of fast. Negative 3 to 3, and then I'm not going to label everything. Okay, there we go. Maybe I will put in a 0 right there. And so here I'm taking a union. So I'm not asking what they have in common anymore. I'm just asking for what part gets shaded, what part is included in any one of these. So now what's happening is, if you look, my intervals are kind of stretching out. Here, they're pulling out. And so here, I can take epsilon to be larger and larger numbers, and it's going to start stretching out that whole number line. And so what that means is this union is going to be the entire number line, or in interval notation, negative infinity to infinity.